Dear students, in this video I am going to explain VSEPR theory. The full form of VSEPR theory is valence shell electron pair repulsion theorem. Valence shell electron pair repulsion theorem was proposed by Sidgwick and Powell. Later it was developed by Nyholm and Gillespie. The main postulates of VSEPRT are: number 1, the shape of the molecule depends upon the number of electron pairs in valence shell of the central atom. Second point, the shape of the molecule also depends upon repulsion between electron pairs. Third point, the bond angle of the molecule depends upon repulsion between electron pairs, and electronegativity depends between central atom and bonding atom. A lone pair of electrons occupies more space along the central atom than bonded pair of electrons. In these 4 points, the first point, you must understand this first point is very important. The shape of the molecule depends upon number of electron pairs in valence shell of central atom. So we always depends on the central atom for the shape and bond angle of any molecule. Next one, the repulsion among electron pairs decrease in the order lone pair dash lone pair greater than lone pair dash bonded pair or bond pair greater than bond pair dash bond pair. That means the repulsion between lone pair and lone pair of electrons and lone pair of electrons is greater than. So there is a more repulsion between lone pair and lone pair than lone pair and bonded pair and bonded pair and bonded pair. And repulsion among triple, double and single bonds decrease in order. So that order is triple bond greater than double bond greater than single bond. Repulsion forces decrease sharply with increase in angle between of electron pairs. Shape and bond angle molecule basing on bonded pairs and lone pairs around the central atom as follows. So look at the table here. The first one is the atom. Second example, bonded pairs and lone pair shape and bond angle. Here the generalized atom molecule is AB2. AB2 means A is the central atom, B bonded pairs of electrons. So example BeCl2. In BeCl2, Be is the central atom and 2 chlorines combined with beryllium. So beryllium chloride. The bonded pairs are 2, lone pairs, there is no lone pairs in beryllium chloride at central atom is 0, though therefore the shape of the molecule is linear and bond angle 180 degrees. Next, second type of molecule AB3. That means central atom is A and bonded pairs, number of bonded pairs are 3. So there is no lone pairs in this type. So example for this model is BCl3, boron trichloride. Here boron is the central atom. The total bonded pairs at the central atom is 3 and lone pairs is 0. Shape is trigonal planar and bond angle 120 degrees. And third type is there is 4 bonded pairs around the central atom. CH4, methane is the example for this model and bonded pairs are 4, lone pairs are 0. Shape is tetrahedral and bond angle 109 degrees 28 minutes. Next model AB5. Around central atom 5 bonded pairs So this model, the example for this model is PCl5, phosphorus pentachloride. 5 bonded pairs, lone pairs are 0, and the shape of the molecule is trigonal bipyramidal, and there is a 2 bond angles 90 degrees and 120 degrees. So in the plane there is 90 degrees and 120 degrees. I will explain with example. Next model AB6, that means 6 bonded pairs around the central atom. Example for this model is sulfur hexafluoride SF6. So 6 bonded pairs, so 0 lone pairs, and shape is octahedral. Bond angles are 90 degrees in plane and 180 degrees perpendicular to the plane. So here AB2E2, that means 2 bonded pairs. E means lone pair of electrons. So we denote lone pair of electrons with E. So AB2E2, around central atom there is 2 bonded pairs and 2 lone pairs. So therefore the example for this model is H2O, 2 bonded pairs and 2 lone pairs. The shape of the molecule is angular and the bond angle is 104.5 degrees, or we can say 104 degrees 5 minutes. Next AB3E, that means 3 bonded pairs and 1 lone pair around the central atom. NH3, ammonia is example. So 3 bonded pairs and 1 lone pair. The shape of ammonia is pyramidal and bond angle is 107 degrees. So let me explain with examples for this Vsepr theory. Structure of ammonia molecule. The central atom in ammonia molecule is nitrogen. It contains 1 lone pair and 3 bonded pair of electrons. Nitrogen in NH3 undergoes sp3 hybridization. So normally if any atom undergoes sp3 hybridization, the shape is tetrahedral at bond angle is 109 degrees 28 minutes. But here, according to Vsepr theory, the repulsion between lone pairs and bonded pair of electrons causes the decrease in bond angle from 109 degrees 28 minutes to 107 degrees, and shape changes from tetrahedral to pyramidal. So even though in ammonia nitrogen undergoes sp3 hybridization, it doesn't have tetrahedral shape and tetrahedral angle, that means 109 degrees 28 minutes. The shape is changed and also the bond angle is also changed because of this lone pair bonded pair repulsions and bonded pair repulsions. Next example, structure of H2O molecule. The central atom in H2O molecule is oxygen. It contains 2 lone pairs and 2 bonded pairs of electrons. Oxygen in H2O undergoes sp3 hybridization. I already told you, if any atom undergoes sp3 hybridization, the regular shape is tetrahedral and bond angle is 109 degrees 28 minutes. But according to Vsepr theory, this theory explains why the H2O molecule is angular and why the bond angle is 104 degrees 5 minutes. According to Vsepr theory, the repulsion between lone pair and bonded pairs of electron causes, this is very important point, the repulsion between lone pair and bonded pairs. You can observe the diagram, the dots, 2 dots and 2 dots, totally 4 dots here. So that means the 4 lone pair of electrons is denoted like this, and 1 line, this is the covalent bond. In this, the bonded pair, we say it is a bond pair. 2 electrons are present in this covalent bond, and 2 electrons also present in right side covalent bond. So these 2 are bonded pairs and the dots represents lone pairs. So because of the repulsion, this shape of H2O molecule changes to angular shape, tetrahedral to angular, and bond angle changes to 109 degrees, actually 109 degrees 28 minutes whenever the sp3 hybridization is occurred. But here the bond angle in H2O is 104 degrees 5 minutes. So that is the end of my presentation. Thank you.